All right, so this is Edgenuity, Algebra 2B. We're going to be graphing exponential functions. You're not really going to graph it. All right, let's get started. Okay, so which set of ordered pair could be generated by the following um, exponential functions? All right, so first of all, you need to understand that the ordered pairs are arranged by x comma y. So all numbers on the left are x values, on the right are y values, okay? So you understand that y equals to base b to the x power. This is the formula, or I should say the equation for the exponential functions, okay? First thing you want to understand is we can eliminate two options, is this one and that one, okay? I'm gonna tell you why, okay? And then you just put x on the side. All right, so first of all, you understand that if x values are 0, okay? So anything to the 0th power, y is gonna equal to 1, okay? So x equals to 0, y must equals to 1. X equals to 0, y must equals to 1. Okay, so I just repeat that twice because I think it's very important. All right, so which means that 0, 0, 0, 0 cannot be your order pair in this case. Okay, so let's look at the other ones. So let me rewrite this: y equals to b to the x power. Okay, so let's just say that this is working. I'm gonna show you why this is not working actually. All right, so if x equals to 1, y equals to 2. Okay, yeah, it's possible. Yeah, yeah, if the base equals to 2, then yeah, it's possible. But if you look at the next one, so if x equals to 2 and then y equals to 5, uh, not really. I don't think that's possible. Okay, so the order pair does not work. Okay, so now I'm gonna show you why the last one works. Oops, sorry. Okay, let me show you why the last one works. Okay, so if I have y equals to b to the x power, and I say that x is equals to 1, and then y equals to 3. Okay, all right, so which means that the base b equals to 3. We're gonna have to keep the base b as 3 consistently, okay? All right, so next one. Now we know that the base is 3, and let's see if when x equals to 2, am I gonna get y equals to 9? Yes, I am. Okay, so that looks like it's about to be true. And the last one, keep it the same base. If x equals to 3, am I gonna get y equals to 27? Yes, that's correct and correct. So the last one is your answer. No, I'm sorry taking too long on this one question. Okay, so what is the domain and range of, okay, this is the one that when base value is less than 1, we have a decay function. So I'm gonna show you guys how a decay function looks like. Okay, so I'm graphing in red. So this is decay function. It's gonna pass through the point 0, 1 every single time. Okay, all right, so in this case, domain is all real numbers. Okay, domain is all real. Okay, but the range is not all real because the range does not get to the negative part of the y. Okay, so this is not gonna be your range. So the range is actually gonna be anything greater than 0 because you keep it above y equals to 0. Okay, so it's gonna be okay, so it's just greater than 0. Okay, so that's why the second one works, is your answer. Okay, so what's the one that's best describe the domain and range for this one? Okay, so I'm gonna graph the one over here first. Okay, so I'm gonna use blue. Okay, so use blue for this one. So if it's a 6 to the x power, it's going to look something like this. This is a growth function, so it's going to look something like that. Okay, now let's use a different color. So I use red. So 6 to the negative x. So that's going to be a decay function. It's going to look something like that. Okay, the same thing between these two is that the domain are both domain is both all real. Okay, for the range, both are above 0. Okay, you see that both of them does not go below this y equals to 0 line. Okay, so they have the same domain and same range. Okay, so next one. So which function represents the vertical stretch? Okay, so I have to say that vertical stretch is the book definition. I personally don't like it, but unfortunately, they're gonna test you with these terminologies. Vertical stretch is basically like this. So, see, like this is my original, right? And if I stretch it vertically, it's gonna get, the difficulty level is gonna be higher, right? So this is gonna be steeper. Basically, this is just a steeper. Okay, you stretch it out, it gets steeper, and that's the one we're looking for, the one with the coefficient that's greater than 1. Okay, so the first one's your answer. All right, so what are the domain and range of the function? So this is the one that you start with the parent function. So I'm gonna show you the parent function for the growth. Okay, so use something light. Okay, so it's gonna pass through the point 0, 1. It's going to look something like that. Okay, now you see that we have a plus 5, so which means that this whole entire curve is going to go up 5. So you're going to go 1, 2, 3, 4, 5. Okay, so it's going to go like that. Okay, domain is still going to be all real. Okay, range is going to be 5 and above. Okay, because it doesn't. So because it doesn't pass below this line. This line is y equals to 5. Okay, my blue curve does not go below y equals to 5. So the range is going to be 5 and above. All right, so which for the following describe the transformation? So we know this is your parent function, and then this is a vertical stretch. So you're gonna look for the word graph vertical. Sorry, stretch the graph vertically. Okay, so by the factor of 3. So 3 is the one we're looking for. You can't choose the middle two. Okay, don't be silly. All right, so what happened is that if you have a negative on x, so negative on x, this is what's going to happen is that it's going to reflect it over y axis. Okay, so you're going to look for the y axis. Up to this point, you can eliminate all answers, and then plus 2, it's going to go up by 2. Okay, so up 2. So choose the last one, please. All right, so which one is the exponent growth function? Growth start from, let me use a red to redraw this. So you're gonna look for this answer, okay, please. All right, so you're gonna start from low, and then it's gonna be flat, and all of a sudden if you pass through is 0.01, and then all of a sudden it's gonna boom, it's gonna go up like that. That's the growth function. I should say this is the exponential growth function. All right, so which one represents an exponential function? Okay, this one actually was a decay function. It came from this. It actually came from this decay function. And what happened is that they had a reflection, so it reflected over. So that's why you see a graph like this, okay? This is an exponential function, okay? Let me clear all my curves so you know that which one you need to pick. All right, so which table represents an exponential function of the form y equals to b to the x power when b is in between 0 and 1? So which means that if it's between 0 and 1, this is going to be a decay function. Okay, decay function means that it's gonna go like that, like you care, right? But let me just go over it regardless. Oops, what the hell is going on, man? Okay, so this is the decay function. Okay, so the characteristic of the decay function, when you have to select, it's start really high, okay, but as the x increases, and then y is gonna decrease and to very low. Okay, so look at this. When x is a negative, it starts from a big value. Okay, as the x increases, value is low. Okay, so that's the one you have to look for. All right, so which graph represents the exponential function? This is the growth function. Okay, look for that. All right, so which one is the exponential equation? All right, so by the table below. So basically what happened is that you look for this 3 and 3, okay? Because that's you have done some transformations over here, okay? So the one you have to do is that you want to look for when x equals to 3, okay? So you kind of just plug it in. You just look for this one, okay? And you plug it in to all the equations and then see which one works. And I'll show you why I'm plugging into this third one, because y equals to 3 to the x minus 3 plus 2. If you plug in x equals to 3, okay, and then what does y equal to? Okay, let's solve for it. So y equals to 3 to the 0th power plus 2. Y equals to 3 to the 0th power. We talked about this earlier. Equals to 1. Anything to the 0th power equals to 1. Okay. So 1 plus 2. Y equals to 3. So look at this. Y equals 3. Okay. So you choose the third one. For this question, let me repeat. I tried 4 different attempts. Looks like they're all the same. Okay. I mean, like the answers are all the same, the layouts. All right, so which function has a range y is less than y? Sorry, y is less than 3. Okay, so I'm gonna tell you why this one is the answer. Okay, so I'm gonna graph this. God damn with my color. Okay, so all right, first of all, let's graph the parent function. So the parent function looks like this. Okay, I look at it as 2 to the x power. All right, so what happened is that I got a negative in front. Okay, so negative in front, what's gonna do is that you're gonna have it like that. Okay, reflected over x-axis. Okay, all right, so you gotta have a plus 3, and what's gonna happen with the plus 3 is that your whole entire it's gonna go up by 3. Okay, so what's gonna happen here is gonna go up by 3. 1, 2, 3. Okay, so you're gonna have something like that. Okay, so that's why you have a range y is less than 3. Okay, so which property represents the exponential function in the form? Okay, so you got y equals to b to the x power, where b is greater than 1. This is a growth function. Okay, so how does that look on the graph? So a growth function looks like this. Okay, so when x, all right, okay, let me use a different one. Okay, so look at this. When x is increases, y also increases. Okay, when x is decreases, and then y is decreasing. Okay, so the only one that looks like it fits to my description, it's the first one. X value increase, the y values increase. Okay, the last one, decrease, decrease. All right, last one. Which ordered pair could be generated by the exponential function? This is the same one that we did earlier. So this time I'm going to show you that the same exponential equation. Okay, so so you're going to go with that one is because let's just say that if x equals to 1 and then y equals to 1/2, which means that your base is going to keep it as 1/2. Okay, so you want to keep this base 1/2 for all of them. Okay, so let's look at it. Base equals to 1/2, and then x equals to 2. See if it does equal to 1/4. It does. Okay, you're going to do the same thing for all of them. You're going to get that as your answer. Okay, so and try to not waste your time. Just try your best on the quiz. Okay, I got 20 attempts for you guys. Keep trying. Take care.